Hello, my name is Joshua Albert. I'm a master's student here at SUNY ESF, and I'm working on my master's thesis proposal currently, and I'm presenting here at this conference for feedback and sort of some personal practice. And my thesis project is evaluating physical and hydrologic soil properties to inform forecast models of soil trafficability. And so trafficability as a whole is the ability of soil to sustain loaded traffic without deforming to a certain degree. So this can technically be applied to any sort of load on the soil, but we will be specifically analyzing it in regards to soil trafficability of forest equipment. So as you can see in like this image, some sort of pickup truck or loader or something drove across the soil and perturbed it to quite a degree, rutting it, compacting it, causing ponding and preferential pathways, which can be damaging and can sometimes be dangerous if it's on a steeper slope or something like that. So the trafficability index that we are considering is going to be entail more of the parameters than listed here, but the main things that we will be looking at are soil moisture, particle size distribution, or clay content, and slope. And our site is in the Hubbard Brook Experimental Forest, which has a lot of this data available. It has been a hydrologic reference watershed since 1956, and it's been heavily instrumented with these groundwater monitoring wells, soil probes, met stations, and very diligent soil classification and modeling, as you can see in this image. The image shows that there's lateral podzolization or different soil formation processes that are a result of topography and influence topography at small scales. And so the main aspect of this project will be to use this measured data that we have, remote sensing data from other people, and field data to create a trafficability index at transects, as you can see in this image, denoted by the black circles. And so once we can gather all this data, we can determine if these hydropedological soil units or just soil units, as a more general term, should guide decisions on when and where to operate within a forested soil. So we want to take these transects, create a trafficability index at a small scale and extrapolate that based on some of the soil moisture slope characteristics of the soil. And this can help us create a conceptual model to then be used as to inform a PhD student's forecast model of trafficability based on a little bit larger temporal timescales. So yeah, I appreciate the opportunity to present at the conference, and I hope to see people there.